Assalamualaikum. My name is Widi Mutakin from Expose Academy. In this tutorial video, I'm going to show you 7 different ways of controlling the camera object in Blender 2.8 or above. But before that, we'll cover the basics first, so at least we have the same starting point. So, why do we need a camera object in the first place? Well, in Blender, there are 3 types of rendering. The first one is the preview rendering. Second is a viewport rendering, and finally the last one is the final rendering. Let me explain each of these methods real quick. Preview rendering is when you activate the render preview mode here. In this mode, you don't need a camera. You can have a camera, but it is not a must. Next is the viewport rendering. You can access this feature by going to the view menu here, and then choose a viewport render image. Basically, it will render what you see in the viewport to an image at any resolution that you like. Now, this feature is useful especially for people like me who make a lot of tutorials or courses, or people who write books about Blender. There are many hidden features that you can use within this rendering method, such as making the background transparent, etc. For this type of rendering, a camera object is also not a prerequisite. Finally, the last rendering type is the final rendering, which you can perform by pressing F12 in Blender, or by going to the render menu here, and then choose render image or render animation here if you are doing animation. This is the rendering method you want to use when you need to produce the highest quality rendering output. And for this type of rendering, you need a camera. If you press F12 without any camera presence in your scene, Blender will just throw an error message. So, you understand by now how important a camera object is. In conclusion, without a camera object, it is impossible for you to get the best rendering result out of Blender. When you first launch Blender, the default scene actually already has a camera object. This pyramid-like object with a triangle head on top of it is the camera object. Just like in the real world, the camera object inside Blender is used to direct the view, so Blender knows what to display when performing the final rendering. You can also animate the camera object to add more dynamics to your animation. But we are not going to discuss camera animation in this tutorial. Now, in the real world, if you are shooting with a camera, you want to look through the viewfinder or see the backscreen of it. This way, you know exactly what the camera sees. In 3D applications, you can do that by switching the viewport to the camera view mode. There are 3 ways that you can do this inside Blender. The first and fastest method is by pressing 0 on the numpad. As you can see, we are now viewing the scene from the camera object. You can see the word camera perspective here. To go back to the user view mode, you can press 0 again on the numpad. Or, you can just rotate the viewport using the middle mouse button. This will also bring you back to the user view mode, okay? The second method is by clicking on this button here. This is a toggle button, so you can click it again to go back to the user view. We can see the word user shows up again here. The last method, which is the slowest one, is by using the menu. To access the camera view mode, you can go to the view menu in the 3D viewport header, then choose cameras, and then choose active camera here. Or, you can also go to the viewpoint submenu here, and then choose camera here. Yes, I know this is redundant. We have 2 commands in the menu that do exactly the same thing. But this is what I have in my current version of Blender. Now, if you don't have any camera object in the scene, then you need to create one. Creating a camera object is very simple. As with any other objects in Blender, you can just press Shift-A and then choose camera here. We can move and rotate the camera object just like with any other objects in Blender. But you don't need to do scaling on them because scaling won't affect anything on the camera in terms of the rendering result. Now, when you have multiple cameras like this, Blender needs to know which of these cameras should be used when performing the final rendering. This is where the concept of the active camera comes into play. You see, when we press 0 on the numpad, we're not just switching the view to the camera view, but we are switching to the active camera view. You can have so many cameras in the scene, but there can only be one active camera. We can tell which one is the active camera visually in the viewport by looking at the color of the triangle head. the active camera will have a solid color triangle like this one, while the non-active cameras have the triangles hollow or only showing the wireframe like this one. Besides indicating which is the active camera, the main purpose of these triangles are actually to indicate the local up direction of the camera object. So this is the up direction when we view the scene using this camera, okay? In the outliner, we can tell which one is the active camera by looking at this icon here. The one with a bright background is the active camera. Now, what if we want to make this camera as the active camera? Well, we can do this in 3 different ways, using the keyboard shortcut, using the menu, and using the outliner. To use the keyboard shortcut, first, we need to make sure that the camera object is selected, and then press Ctrl 0 on the numpad. The selected camera is now the active camera, and the viewport also changed to the camera view mode automatically. We can see that in the outliner, this icon now has a brighter background color. And also, if we rotate the viewport, we can see that this camera now has a solid triangle head on top of it. The second method is by going to the View menu, then Cameras, and then choose Set Active Object as Camera here. And the last method is by going to the outliner and just click on this small camera icon. There are 3 things that I want to discuss in terms of the camera settings in this tutorial. First is the image aspect ratio. If you are inside the camera view, you can see a dark area surrounding a rectangular frame. When you do the final rendering, only the area inside this frame will get rendered. Anything outside the frame or in these dark areas will be ignored. Now the question is, how can we change this rectangular shape then? Well, this is actually not part of the camera settings, but part of the render output settings. So it affects not just a specific camera, but all cameras exist in a scene. To control this, you need to go to the Output tab in the Properties editor. For example, if I change both the X and Y resolution values to 2000 pixels, we get this square shape of 1:1 image aspect ratio. If we change the X resolution to 1000 pixels, for example, then we get this portrait image aspect ratio. From these examples, we can conclude that to get the most image out of our rendering without any cropping, then we should use a square image aspect ratio, which basically using the same numbers for both the X and the Y image size values. Also, from these examples, we can see that changing the image resolution does not change how much wide the camera can see. It only changes how the final image will be cropped. So the next question is, how can we widen the camera view then? Well, this is the second parameter we are going to discuss, and this parameter is actually part of the camera object. So click here to open the camera settings. Here, you can find the focal length value. Blender uses a real-world camera property, which is basically the lens millimeter value, to define the camera's view angle. The smaller the value, the wider the view angle, but at the cost of stronger perspective distortion. The larger the focal length value, the narrower the view angle will be, thus reducing the perspective distortion. If you have experience in photography, you may feel right at home playing around with this lens millimeter value. But if you come from other 3D software that happens to use angle degree instead lens millimeter to define the view, you might want to use angle degree also in Blender. You can do that by just clicking here and choose field of view. Now you can control the camera's view angle using degrees instead of lens millimeter. Finally, we are at the main section of this tutorial where we will discuss different methods of controlling the camera object inside Blender. So there are at least 8 ways that you can use to control the camera object. The first one is the manual transformation. Second, the camera view local transformation. Next is using the align to view feature. Then using the lock to view feature. Using the walk navigation control mode. Then using the fly navigation mode. Using the track to feature. And finally, using the follow path feature. Now, out of these 8 methods, we'll be covering only 7 of them. We are not going to cover the fly navigation mode, as I found this method to be very hard to control. But the way this fly navigation works is almost similar with how the walk navigation works. So you should be able to use it once you understand how to work with the walk navigation mode. Let's discuss each of these methods one by one. The first one is the manual transformation. Basically, with this method, you just select a camera object and then move it using the Move tool or by pressing G for the shortcut. You can also rotate the camera using the Rotate tool or use the R shortcut. Now, for this method to actually work, you need at least another viewport set as the camera view. For example, we can split this area vertically, then hover the mouse on this area and then press 0 on the numpad to turn it into a camera view mode. You can see as I move or rotate the camera in the left view, the camera view at the right side updates accordingly. The next method of controlling the camera is right within the camera view without any additional split viewport. Basically, we will use mostly the local axis of the camera. If you select a camera object and then change the transformation orientation here to local, and you have the Move tool active, this is how the local axis of the camera aligned. Up and down is on the y-axis, with positive y as the up direction. Left and right is on the x-axis, with positive x as the right direction. And finally, the forward and backward directions are on the z-axis. Positive z-axis is actually the backward direction, and negative z-axis is forward. Just remember these local axes as we are going to use them frequently in the next discussions. If you press 0 on the numpad so you are inside a camera view, you can actually select the camera object by clicking on this frame. If the frame turned yellow, then you know that the camera object is currently selected. Sometimes, if you have the camera selected and then you click on an empty space like this, it is hard to reselect the frame again. To get around this, you can click on any object in the scene to select it, then select the camera object again. Or you can use the B shortcut to create a box selection like this that crosses the camera frame. You can also select the camera object from the outliner if you want to. After you are sure that the camera object is selected, you can now perform the local transformation method. To make things consistent, make sure you have the transformation orientation here set to global. This is important because the transformation shortcuts work a bit differently if you are in the local transformation mode. Okay? The first keyboard shortcut is G. We can use this to pan the camera left, right, up and down based on our current viewing direction. The next one is pressing G, then followed by pressing Z twice. Pressing Z twice is a way of telling Blender that we want to use the local Z axis of the camera. If you only press Z once after pressing G, then the global Z axis is used instead. So again, press G, then Z again. Now we can move the camera forward and backward by moving the mouse up and down. This type of camera movement is commonly known as dolly in cinematography. Next, let's discuss camera rotation. We can rotate the camera using the global Z-axis by pressing R, then followed by Z. This type of camera rotation is also known as panning in cinematography. The next camera rotation is tilting. To tilt the camera, we can use the local x-axis as the rotational axis. So press R and then press X twice. We can see we are tilting the camera up and down. The last one is rolling. This type of camera rotation is commonly used in fly-through camera motions, rarely used for headshots or common static shots scenarios. To do a camera rolling, you can press R and then followed by Z twice. We can see how the camera rotates using its own local Z-axis. So that is the second method of controlling the camera transformation. The next method we are going to discuss in this tutorial is aligning the active camera to the current user view. Let's say we are in the user view mode, and after rotating the view and adjusting the zoom, we happen to like the viewing angle, and we want to use that view for the final rendering. Remember, final rendering needs a camera, and right now, we are viewing the scene in the user view mode, not in the camera view mode. So essentially, we want to make the active camera to reposition and align itself to the current user view. To do that, we can hold Ctrl, Alt, and then press 0 on the numpad. Or, if you forget the shortcut, you can always go to the View menu, then Align View, and then choose this command here, Align Active Camera to View. As you can see, Now the active camera has changed, and it is now viewing the scene just like how we see the scene before in the user view mode. The fourth method of controlling the camera is by using the lock to view feature. Now this feature is very interesting. Essentially, with this feature, you can control the camera as you would normally control the user viewport mode. To activate this feature, you can press N to open the sidebar panel. In the View tab, you can find this option, Lock Camera to View. If you turn this on, now we can perform any typical viewport navigation operations, such as dragging with the middle mouse button to rotate the view, zooming in and out using the mouse scroll wheel, and panning the view with the shift and middle mouse button combination. All of these operations will affect the active camera object's transformation automatically. After you are done adjusting the camera with this mode, don't forget to turn this off again. The fifth method of controlling the camera is by using the walk navigation method. If you played FPS games before, you may already accustomed to using WASD letter keys to move, while at the same time using the mouse to look around. Well, in Blender, you can do that also. This method can be useful if you are designing a game level or a VR project inside Blender and you want to navigate the space like how the users will navigate it later. So to do this, you need to go to the View menu, then Navigation, then Walk Navigation. You can see Blender also provides another navigation method called the Fly Navigation. But I found this method to be very hard to control, so I need to skip this one. Let's just focus on the walk navigation for now. Personally, I always prefer to use shortcuts than menus as they are just faster to perform. For the shortcut, you can press Shift X engrave or tilde key to activate the walk navigation mode. It is the key just below the escape key. When the walk navigation mode is active, the mouse cursor will be hidden and replaced by a crosshair at the center of the viewport. In this mode, you can pretty much navigate the viewport using the common controls found in FPS games. You can direct the view orientation by moving the mouse around. You can press W to move forward, press S to move backward, D to move to the right, and A to move to the left. Those are the basics you probably already know. But besides those keys, you can also press E to elevate upward and press Q to drop downward. In this mode, you can make the movement faster by holding Shift. Or, if you need to move slower, you can do so by holding the Alt key. Besides using the Shift and the Alt key, you can also set the speed gradually using the mouse scroll wheel. Scroll up to make the movement faster, and scroll down to make the movement slower. After you are done navigating, there are two things that you can do. If you want to keep the current view, then you need to left-click. But if you want to cancel and go back to the previous view that you have before, then you need to right-click. Now, to really use this method to control the camera view, first, you need to be in the camera view. Then after that, activate the walk navigation mode either by going to the View menu or simply by pressing Shift X engrave. Now, in order for this to work, you don't need to activate the Lock Camera to View option here in the sidebar panel. Although, if you have this turned on already, it will work also. After you are done, remember to left-click to keep the changes, or right-click if you want to ignore the changes and revert back to the previous view. Now, the walk navigation method also offers a special mode called the gravity mode. In this mode, Blender will detect surfaces beneath our camera object. In order for this to work properly, of course, you need some kind of surface that we can walk on. Otherwise, the camera object will just fall down infinitely. So, create a plane object first, and then scale it up so it is wide enough for us to walk around on top of it. I already created this object before recording. Now let's go back to the camera view by pressing 0. Then activate the walk navigation mode by pressing Shift X engrave. Now we are in the walk navigation mode. To activate the gravity mode, you can press Tab. Notice how we fall and stay on the surface of the plane object. While in gravity mode like this, we can press V to jump. And one last feature that may come in handy in the walk navigation mode is the teleport feature. If you see a surface and you want to teleport to that surface immediately, You can target it by moving the mouse so that the crosshair is exactly pointing at that surface. Then press spacebar. As you can see, we just teleported to the surface location that we targeted before. Next, let's discuss the track to constraint method. If you come from 3ds Max or other similar 3D applications, you might already be familiar with using a camera object that tracks another object as the viewing target. In some 3D applications, this is the default camera behavior. In Blender, however, camera objects are free objects by default, meaning it does not constrain to be looking at a certain object. But if you do need to make the camera object to always be looking at a certain object, you can set this up easily in Blender using the track to constraint. So to do this, first, make sure the camera object is selected. Then, in the Constraint tab, click the Add Object Constraint, and then choose Track to. Because this constraint will force your camera to always be looking at another object, of course, you need that other object for this setup to work. You can create an empty object and use that as the target object. For now, I'm just going to use this object as the target object. After you have pointed an object as the target object, you need to set up the axis. Remember our earlier discussion about the camera axis? The forward direction is the local negative z-axis, so make sure you pick this negative z option. Then also remember that the up direction of the camera is the y-axis, so make sure you have this up option set to y also. And that's it, you are done. Notice if I move the object around, the camera will follow automatically. Now, in the parameters of the constraint, you can find this option Target Z. Mostly, you don't want this option turned on, because if it is on, the camera rolling will be controlled by the target object's rotation. So if I rotate the target object like so, the camera will follow by rolling accordingly. So that is what this Target Z option does. Now, if you change your mind and decided to free up the camera object, just remove the constraint by pressing this X button here. Now the camera object is free again, just like before. The last method we are going to cover in this tutorial is using the path follow constraint. This method is great for creating guided camera animation. For example, if you want to create a walkthrough animation, a fly-through animation, or a roller coaster type camera animation, etc. To set this up, you will need a curve object for the path. I already created this path here before recording the tutorial. Next, you need to reset the camera position and rotation. To do that, make sure the camera object is selected, then press Alt-G to reset the position, then press Alt-R to reset the rotation. You can see the camera object now moved to the center of the world and now is facing straight down. Next, open the Constraint tab, Add Constraint, and then choose Follow Path here. In the target field, you need to pick the curve object you want to use as the path. Change the forward option to the negative z-axis and the up direction to y. This relates to the camera local axis we discussed earlier. Then finally, turn on the follow curve option here to make the camera facing the movement direction automatically. We are not going to discuss camera animation in this tutorial, but if you do need to animate the camera, then you can animate this offset value here. As you can see, the camera will move along the path as I drag the offset value. Now, what's so great about constraints is that you can combine them. In this setup, you can see that I have created a circle curve for the path, and then a camera to follow that path. Then I added a track to constraint so that the camera is always looking at this object at the center. With this, we can create a turntable-like animation to showcase our 3D models, for example. Okay guys, if you want to learn more about computer graphics, perhaps you want to jump into the video game industry, or perhaps you want to create digital assets that can generate passive income, or you want to have a career doing something you really love, or become an entrepreneur in a creative industry and build your own design firm. Or maybe you just want to learn CG as a hobby, then you should check out my courses at Udemy or at Skillshare. The links are in the description below. Currently, I have courses in Blender, 3ds Max, Photoshop, Adobe Illustrator, and Krita, and more to come inshallah. All of these courses will guide you from the very basic, step by step, until you can master the skills that you need. As always, subscribe to my channel, share the video, give a thumbs up if you like the video, and give a thumbs down if you hate the video. Check out my other tutorials. Wassalamualaikum.